Welcome to Get Your FRQ On. This question is from 2013. It's question 1, and it is calculator active. In this question, we have a gravel processing plant, and we have a couple of functions. We have a function g of t, which gives us the rate at which unprocessed gravel arrives at the plant. The plant already has 500 tons of unprocessed gravel at the beginning of the workday. And while the plant is in operation, it processes 100 tons per hour. And in part A of this question, we are asked to find g prime of 5 with units and the interpretation of this value in context. So we're given the function g of t, that is 90 plus 45 cosine of t squared over 18. We can find g prime of 5 by first finding g prime of t and evaluating g prime of 5. It's fairly straightforward if you know your differentiation rules. G prime of t is negative 5t times the sine of t squared over 18. This isn't entirely necessary. This is a calculator active question. So if you're going to evaluate this at 5, use your calculator to evaluate it. It turns out to be about negative 24.587. And then keep in mind we do have to provide an interpretation of this value in context, right? So we found the value. The rate that we're talking about here, g prime of 5, right? Because g of t is already a rate function, g prime of t is the rate at which the rate is changing. So this value indicates that the rate at which unprocessed gravel is arriving at this plant is decreasing, because g prime of 5 is negative, at a rate of 24.587 tons per hour at t equals 5. In part B of this question, we are asked to calculate the total amount of unprocessed gravel that arrives that day. So total amount is just going to be a definite integral. We're not taking into account how much gravel is being processed or how much was there to begin with. We're only talking about how much did arriving gravel contribute to the amount of gravel at the plant. So this is just going to be a definite integral. We're given in the question stem that the work hour or the work day is 8 hours. So we just need to calculate the definite integral from 0 to 8 of g of t dt. So we can set that up, but again, this is a calculator active question. This is probably not something you're going to want to do by hand. We're going to let the calculator do the hard work here. And it turns out that that definite integral has a value of 825.551, which simply means that during the 8-hour workday, 825.551 tons of unprocessed gravel arrived at the plant that day. In part C of the question, we are asked to find the amount of unprocessed gravel and determine whether it's increasing or decreasing at t equals 5 and to show work. So the amount of unprocessed gravel will take into account the rate at which gravel is arriving, the rate at which it's getting processed, and how much, well, whether it's increasing or decreasing. It's just going to take those two rates into account. So define a new function a of t for amount of unprocessed gravel. The actual value of this function will be 500, our initial value, plus the definite integral from 0 to t of g of x minus 100 dx. All right, so that integrand is taking into account the rate at which unprocessed gravel is arriving and at which it's being processed at the plant itself. All right, so we can write that as a function. That's 500 plus the integral from 0 to t of 90 plus 45 cosine x squared over 18 minus 100 dx. That's our function. To determine if this is increasing or decreasing, we need a derivative for this function at t equals 5, which conveniently the 500 has a derivative of 0 if you know your fundamental theorem of calculus. A prime of 5 is just g of 5 which is going to be whatever the value of 90 plus 45 cosine 25 over 18 is. Again, calculator active question, so use your calculator. It turns out that a prime of 5 is positive 98.141. Now, since the plant is already processing gravel at a rate of 100 tons per hour, and unprocessed gravel is only showing up at a rate of 98.141 tons at this time, that is less than the rate at which the plant is processing the gravel. So at T equals 5, the amount of unprocessed gravel will be decreasing because it's being processed at a faster rate than it's being delivered. In part D of this question, we are asked to determine the maximum amount of unprocessed gravel that day and provide justification. All right, so if we go back to our A function, A of t equals 500 plus the integral from 0 to t of g of x minus 100 dx. All right, that's the amount of unprocessed gravel at the plant at time t. Then the amount of unprocessed gravel will be at a maximum either somewhere where the derivative of a, which is equal to g of t minus 100, is equal to 0, or possibly at one of the endpoints 0 or 8. We're not really sure. It could be at an endpoint. All right, so a prime of t is just g of t minus 100. If that's going to be 0, all right, that means that g of t equals 100, and you can use your calculator to find a solution to that equation. The time at which that happens will be t equals 4.923. All right, but now we have to evaluate our amount function there to see how much actual unprocessed gravel is there at that time. And then we have to compare that to the amount of gravel at the endpoints. So just checking, the question stem says they started with 500 tons, so A of 0 is 500. The value of A at this value of T, 4.923, is 635.376 tons. And at T equals 8, the amount of gravel there is 525.551 tons. So the maximum amount is at T equals 4.923. And since A of 4.923 is 635.376, that is the maximum amount of unprocessed gravel at the plant that day.